in class today, you might want to review of how to fold this. So you simply take the right side, bring it up to the middle line and make a crease, and repeat with the opposite side. I know it's off just a bit, so don't worry, it'll be just fine. And I told you guys that we would do the easy part together on the notes, so let's begin. So the easy ones, we would recognize they're easy because they have the same coefficient. So if they have the same coefficient, go ahead and flip it on open, and we're going to see some examples of just that. Let's take a look at our addition example of 4y plus 3x is equal to 22 and 3x minus 4y is equal to 14. I'd like to rearrange the equations to line up the variables and constants using the commutative property. Doing that would look like 3x plus 4y is equal to 22. All I've done is moved my 3x on over, so now the second equation in the system now lines up with the variables and constants. Specifically, each column, x, y, and constants are all lined up now. Of course, we use the commutative property on only the first equation. So let's move on to adding or subtracting the equations. Now, obviously, on these two equations, I would choose addition on the addition example because if we take a look, we add straight down, we get 6x, but then by choosing addition, I have caused my y values to eliminate, and that's honestly our goal, is elimination, and now I have just 6x is equal to 36. This makes our next step of solving the one variable equation very simple because all I have left to do is get x alone by dividing both sides by 6, which reduces to 1 on the left side, leaving me with x is equal to 6. Last step, substitute the value of the variable into, oh my god, I got rid of that typo, one of the equations to solve for the other variable. So let's try that out by substituting back in 4y plus 3x is equal to 22. As you've noticed, I've highlighted our x variable in green, so let's substitute. So now we have 4y plus 3 times 6 is equal to 22. Of course, let's go ahead and multiply, giving us 4y plus 18 is equal to 22. And just as before, let's go ahead and remove the constant. By using the inverse operation, we'll subtract 18 from both sides, eliminating it and leaving us with 4y is equal to 4, and lastly get y alone by removing the coefficient using division. The left side reduces to 1y, leaving us with y is equal to 1. Lastly, write your solution as a coordinate or ordered pair, like so. Now we'll go ahead and move on to our subtraction example. Now in this first example that we just finished, you'll have noticed that we used addition because the two that we wanted to eliminate have inverse operations. So let's go ahead and take a look at our second example, subtraction. After analyzing these two equations, you'll notice that we already have them first off lined up, all the columns, all my x's, all my y's, and all my constants. Now, as you take a look, we see here that we have the exact same y's. So you'll recognize that you need to use subtraction because the column that you want to eliminate actually has the same operation. So because of that, let's go ahead and subtract. And truthfully, it doesn't matter which one you want to subtract. Now, after analyzing them, I can subtract either the top one from the bottom or the bottom from the top. I think I'm going to choose, I see smaller numbers down here, I'm going to subtract these. Now, what most people forget is that we are subtracting every single column from each other. So what I'm going to do is I'm going to go ahead and distribute this to each column and then rewrite it. So I'll get negative 2x, negative times a negative, that would be plus 3y, and then minus 11. Now, obviously, this will eliminate. and bring everything else down, and you're left with 4x is equal to 16. Obviously, we're going to solve the one variable equation now, just as last time, using division to get x alone. And 16 divided by 4 gives you, of course. Now that we have x is equal to 4, we're going to move on to our next step of substituting the value into the other equation. So, here again we get to make a choice. Taking a look back at these two equations, personally, I'd probably go with this one because it has smaller numbers. 2 and 11 are smaller than 6 and 27. Hey, your choice, boo do you. But me, I'm lazy. So let's go ahead and substitute 4 in for x, and it'll look like this. Now, obviously, just like last time, we need to distribute and solve for y. So distributing, we get 8, because we distribute the 2 to the 4. It's the same as multiplying, and bring everything else down. Now we're going to remove our constant, just like last time. This time our constant is positive 8. So obviously I will use subtraction to eliminate my positive 8 from one side for me to bring it to the other side of the equation. Let's bring everything else down now. Hey, that looks really simple. Now I need to remove my coefficient, negative 3, which is being multiplied by y. So the inverse operation of multiplication is, you guessed it, division, of course. Now I'm going to divide by y's coefficient. So that means I'm going to divide by negative 3 on both sides, because negative 3 over negative 3 is 1. Now here I'm left with y is equal to negative 1. So lastly, write your final solution as an ordered pair, 4, negative 1. All right, we did our first two easy equations together. Now whenever we come back to class, we're going to finish our last two and adhere this onto a piece of scratch paper and place it into the binding. I'll see y'all then.